Alright, consider this chemistry question. Which of the following reactions does not take place in the smelting of iron in a blast furnace? Very good. So there are certain terms there are certain concepts I need to explain here. First of all, what is smelting of iron? So this is the process where iron is extracted from its ore. So the ore of iron is what we call the hematite. Hematite. So this is a rock particle. So the chemical formula for hematite is Fe2O3. So that it is an oxide of iron. So that is iron 3 oxide. So what we need in the whole smelting process is how can we remove this hydrogen? How can we remove the iron and remove the oxygen? How can we extract this iron and remove the oxygen? So the process of removing oxygen is called reduction. So we can reduce this to remove the oxygen. So this removal of oxygen is not an easy process. That's why we need smelting of iron. Now, the container where the whole of this process takes place is known as the blast furnace. It's known as the blast furnace. It's always looking like the fractionating column that we use in fractional distillation. So it's like a cylindrical, it's like a vertical column too. So let me make a small drawing of that. Make a small drawing here. So it's always looking like this, like traditional pots. So this is the bottom. So then we have the top, which contains about 3 inlets, or you call it outlets. So where gas pass. So this is the bottom. The bottom is about 2000 degrees Celsius and the top is about 1000 degrees Celsius. So this is where the iron will settle. So at this bottom that is very hot. So this is the blast furnace. Now, what are the raw materials that we need in the smelting process? First of all, we need the hematite, which is the iron that we want to separate. So hematite, which is the iron ore. Secondly, we need coke. Coke is an impure form of carbon. You know, carbon has 2 pure forms, diamond and graphite. But impure form of carbon is coke. And finally, we need limestone, which is CaCO3. So which is calcium carbonate. So these are the raw materials that we need. So the first stage involved in this smelting process is that ordinarily, for us to reduce the iron, that is iron 3 oxide. So we are supposed to just add carbon to it, this coke, and then that will give us Fe standing alone plus CO2. So this is just what we should have done. But carbon is not a strong enough reducing agent. Actually, it's a reducing agent, but not a very strong reducing agent that is capable of extracting the oxygen. So in that case, carbon alone will fail. So we now need certain process to first of all follow. So the first process that we need is combustion. So that's step 1. Combustion. Combustion, if you check the option, combustion is when you heat carbon in the presence of oxygen to produce carbon 2 oxide. So that is C plus O2 to give us CO2. So this is combustion, when you burn carbon in the presence of oxygen. So if you check the option, this is part of it. This is part of the process. So that means this cannot be the answer. This is part of the process. This is the combustion process. Now, that carbon, this carbon 4 oxide also is not a strong enough reducing agent that can still reduce the iron 3 oxide. So this is still not enough. Now we need the second process, which is gas formation. Gas formation. Under gas formation, this CO2 will now combine with carbon again. That is CO2 plus C to give us CO. So you can balance the equation. So it will give us CO. So now, this is gas formation. This CO it's a dangerous carbon. It's a dangerous oxide of carbon, and it is very poisonous. And at the same time, it's a strong reducing agent which is capable of reducing the ion, the Fe2O3. So this is capable of doing that. If you check the option, you will see that this is also part of the option. Option E is also possible. So that means this can also not be the answer. Next step after that is the gas, is the oil reduction. Oil reduction. Or before that, you know, after when you have produced the CO2, after when you have produced the gas, which is CO, there will be some impurities inside it. You now need to remove those impurities. So that is where the function of this calcium carbonate comes into play. So we need decomposition. So that's the step 3. Decomposition is step 3. So actually, you need calcium oxide. So it is the calcium oxide. You know, every rock always contains some sand particle. So we want to remove those sand particles. We don't need them inside this blast furnace. We want to remove them away. So we now need calcium oxide, which is quicklime, to combine with silicon dioxide in order to form what we call slag, which is calcium silicate. So I'm coming there. So, but before that, we first need to decompose this calcium carbonate. So the calcium carbonate will decompose to CaO, which is calcium oxide. So, and oxygen will be given, CO2 will be given off. CO2 gas will be given off. So this is the decomposition of calcium carbonate. CO2 gas will be given off. So now, this is what we actually need for the next stage. So this is calcium oxide, which is known as quicklime. So that is step 4. Check the option if we also have this. So this is even option A. So since this is part of the process, that means this can also not be the answer. The next stage is the formation of slag, which is slag formation. Slag is also known as calcium silicate. So this calcium oxide will combine with sand particle. Sand is silicon dioxide. So to form calcium silicate, which is Ca, so which is CaSiO3. This is what we call slag. So this is the next process, which is step 4. So you can see that this is also part of the process. Yes, this is also part. So it means this cannot be the answer. Then the final step is oil reduction. That's the step where we are going to remove the oxygen and have our ion. So which is step 5. That's oil reduction. So removal of the oxygen. So from there, Fe2O3 will combine with the calcium, we combine with the CO, which is calcium, which is carbon 2 oxide. So from there, we are going to have Fe, which is pure ion, to form CO2. So that is the reaction that will happen at last, to form CO. This is the reaction that will happen finally. So we can just balance the equation to see what's going on. Now, if you check the options, you will see that this is supposed to look like this, but it's never the same. So this is Fe. So we have oxygen. So what we have here is never possible. So what has happened here is oxidation of iron, which is a further problem. So what we want to remove is what they are now adding again. It's as if you are adding oxygen to already pure iron to form another problem, to create more problem. So this is not part of the process. So that means the correct answer is option C. Thank you.